All right, please welcome our first post-lunch speaker, Heli Helskyaho, on topic of basics of machine learning.
Thank you very much. I am so impressed. This is a big room and almost full, so thank you very much for joining my session. So, my name is Heli, and I come from Finland, so my Twitter handle is Heli from Finland. It's easy to remember. The last name is impossible. He can pronounce it because he's from Finland, but nobody else can. So Heli from Finland is how people call me. Today we talk about the basics of machine learning. Very briefly about me before we go to the topic. I have graduated from the University of Helsinki with a master's degree in computer science and currently working on my doctoral studies. And surprise to everybody, the research I do is related to machine learning. That's why I talk about this topic. I also teach at the university, and I spend quite a lot of time with all kind of articles about interesting things. So if you're more interested about those things, I have plenty to share. I've been working with Oracle products for a very long time, so I was thinking I will give you some examples of machine learning in Oracle world, if you're interested in that. Most of the time I use Python for my exercises, when I test my theories, but I wanted to share some Oracle knowledge as well, so that you know that it's also possible with their products. I'm a CEO for Miracle Finland, which is a small consulting company in Finland, and anything to do with data and databases is very close to my heart. So it's very easy to understand why I ended up with machine learning, because it's all about data. I'm an Oracle ACE director and a Groundbreaker ambassador. Actually, I'm the first one in Finland as Groundbreaker ambassador, and the first one with both titles. There's actually about 10 female ACE directors in the whole planet, so finding one like this is not everyday thing. So, special thing. I have been listed as one of the top 100 influencers in IT sector in Finland for actually 5 years in a row, since 2015. Every December, they announce the new list of 100 people that are influencing IT in Finland. So every December, I'm like, let's see what happens. This year last year I was lucky again. This year I'm still waiting for December to come. I speak a lot. You know, Finns are known to be very quiet people. I'm not one of those. So I'm a typical Finn, but not with my speaking. I do speak a lot. I go to about 20 events every year to talk and present about different topics. I have also written a couple of books. The first one about Oracle SQL Developer Data Modeler and how to design databases using that. And the second one I co-authored with other people about SQL and PL SQL. As I mentioned, the ACE program, if you're interested about that, there's a slide about the program itself. And now to the topic. I have so much to share with you, so this will be tough to fit in 50 minutes. So what is machine learning? The reason I want to start with this is it depends on who you talk to. They might define it differently. So I want to share my opinion of the definition first. Machine learning is, of course, an important part of artificial intelligence. It's kind of the brain or the heart of artificial intelligence. Machine learning teaches computers to learn from experience, the algorithms, and the data. It learns from the data and makes predictions. That's kind of the principal idea. When we go to reinforcement learning, I will say something else. But the basic thing about machine learning is that it's making predictions. It's about mathematics, statistics, and so on and so on. It's a field of many, many sciences, and I would say it's a team play. So if one person can do everything, that's fine, but usually you need many people in the team to be able to do machine learning. Well, Mr. Arthur Samuel said in 1959 that machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. I would say it means that if you cannot write if-else program, you might be touching machine learning. If you are able to do it with if and else and so on, so you have simple rules you understand, and you are able to program that, forget machine learning. So machine learning is for more complex things. So 1959, that is true. That's when he defined machine learning. So machine learning is not something we invented last year. It just happens to be something that we talk about so much today. Why is that? Well, I will explain. Another way to define machine learning is a systematic study of algorithms and systems that improve their knowledge or their performance with experience. So why are we talking about machine learning today? Well, we have improved technology. In 1959, he was not able to do the things that he was actually planning to do or wanted to do. But today, we are more able to do those things. The price of storage solution has gone down, so we are able to store all the data that we have. So we have more data, and we are able to store it, and therefore we are able to use it as well. But also, the environment we live, it actually needs machine learning, because we need to make decisions very fast, and we can't do it manually. I'm sure you all have bosses that say that I can't wait for the report until lunch, I need it in the morning when I come to the office. So we need to be faster with all these reports and decision-making tools. So we need to do a lot of things automatically. So artificial intelligence and big data are the things that actually push us to use machine learning. Big data is a word I really dislike a lot, because it somehow implies that there's a certain size of a data that defines it to be a big data, but there is no. There is no small, medium, and big data. There's just data. So it's not about size, it's about the processing of the data that actually makes it big data. Of course, it's a lot of data as well, but mainly it's because the traditional way that we have been processing the data does not work anymore, for some reason. It's of course the volume, there's a lot of data, but we have had a lot of data always. Like if you're working for an operator, telephone operator, there's a lot of data all the time. But that's not by itself, it doesn't make it big data. Velocity means that there's always changes. The data is flowing in while we are trying to analyze the data. It's streaming all the time. And we don't have the full data to able to analyze it. It's coming, and we poor things are trying to analyze it. So it's the velocity as well. And last but definitely not least, the variety. So it's not just our own relational database data that we are using for decision making. It's all kind of data, different formats of data sources, different forms of data, structured, semi-structured, unstructured, all kind of data that we should be able to use for decision making. And all these together, or two of these, or whatever combination, makes it big data. Because the way we used to use the data does not work so much anymore. It's also about different V's. It's about veracity, which means the uncertainty of the data. So the invoicing system we have and the database for that, that's accurate data. We know this customer has not paid. This customer has paid. There's no question about it. But if you use data from different sources, how do you know it's reliable? From Twitter, Facebook, somewhere, how do you know it's true? So we have to take a different perspective to the data. It's not always a fact and true data. Viability means that we need to validate hypotheses before we take further actions. So I have been in Los Angeles once in my life. I landed to Los Angeles, it started raining. If any of you has been to Los Angeles, it is a special thing. It never rains. So the data and machine learning would say, when Heli comes to Los Angeles, it always rains. It's a fact. But we know it's ridiculous. I don't have that. Well, maybe I have the power. I went to Boston the next month and it started raining again. So I might have this power. But anyway, we probably think that this hypothesis is wrong. So she doesn't have that kind of power to change the weather. It's also about the value, the potential value of the data. So depending where, what context the data is, it might be very valuable or no value at all. Let's take a wonderful example of cat videos. So cat videos are worth nothing. But I like cat videos, so I just store them somewhere very far from the main system, but I just want to see the cat videos every now and then. Then the boss comes and says, Heli, how do we find those customers who like cats? Because we have this new commercial campaign. We want to reach those customers that loves cats. I'm like, probably those people who post cat videos like cats. So where do we find that? I'm like, well, I have that data, but it's very far. So if we want to use it with machine learning, I kind of need to bring it a bit closer to a faster system that I can use for machine learning and so on. So do that. Be fast, because we need this information now. So the value of data can change. Something that is not valuable at all, one day is very important. And something that is so valuable today might be completely useless tomorrow. So the value of data is changing. And it's really an important factor for how you store the data, how you use it, and so on. It's also about variability, which actually means the meaning of the data, which depends on the context. So in one context, the data is something. In another context, it might be completely opposite. And then visualization. This is something I cannot highlight too much, because visualization is one of the main things when you have a lot of data. We don't like to read Excels with billion rows. We want to have graphs. We want to have some kind of visualization of the data to be able to understand it. And the biggest problem with visualization is that those people who understand the data, the business experts, they are not technical people. So you can't tell them, use Python code. That will help you to find the information. They are like, what is Python? It's a snake? No, it's not a snake. Okay, I'll do it for you. So it has to be a way for them to easily get the data in visualized form. So we have more and more data, the volume, different data models, different data formats, the variety. The loading is in progress while we are trying to explore already the data, the velocity. Not all the data is reliable, the veracity. We do not actually know what we are looking for. We have a lot of data and we want to find something interesting from the data. So it's the value, viability, variability, and we must be supporting those non-technical people who are the business area experts. Journalists, maybe investors, politicians, people who are completely non-technical. And we need visualization for that. And the problem is that all this must be done efficiently. We can't do it slowly, manually. We need to do it very fast as possible. And the only solution is that we do it with machines. So the machines will do the work. They can do it 24/7, parallel and so on. It is a completely different story if I do it manually 7, 8 hours every day than the computers doing it all the time, parallel. So when to use machine learning? This sounds stupid, but when you have data. That's number one. If you don't have data, machine learning is not worth anything. Exception is if we talk about reinforcement learning, but we'll skip it now. And now I talk the basic machine learning here. So you need to have data to be able to do machine learning because it's all about data. Part of the data, if we do, part of the data we use for actually training, and the rest of the data we use for testing that it really works. So you need to have a lot of data. You would use machine learning when the rules and equations are very complex or constantly changing. My favorite example about constantly changing is I try to be a very cool mom. I have 2 boys. The younger one likes fashion. So he tells me these hoodies are very popular. By the way, I tell you, there's 2 things with these hoodies that are very popular. The name is impossible to pronounce, and the price has a lot of zeros. That's what I have learned. So anyway, I learned this brand I cannot pronounce, I write it on a paper, is popular. I travel, I find those hoodies, and I bring it home, and I'm so proud. I'm the best mom in planet. Do you know what happens? Mom, those are so last season. Nobody wears that brand anymore. And I'm like, but you know it cost like 600? Are you sure? No, nobody wears them anymore. So I can't buy anything because this happens every time, and I can't afford to that. But think about machine learning. Machine learning would tell me when I travel, next week this brand will be popular. So I will buy this hoodie, I come home, my son says, oh mommy, nobody wears that. Next week he comes to me, mommy, you are so cool, everybody wears these hoodies. So I was the first one on the planet who had the hoodie. So machine learning would be working for my personal life very well. But still, I don't know how this would work, how to know the hoodie brands. So if you know, let me know. This would be very useful. So the nature of the data changes, and the program must adapt to that. So it's not if else you can program. It's something that is changing constantly. So like spam filters or something like that, you never know what actually is the spam of tomorrow. So if it's something that has complex, changing rules, it might be machine learning that you are looking after. But it's not a silver bullet, so if you have a problem, machine learning is the solution. No, unfortunately not. Real-life use cases for machine learning would be spam filters, as I mentioned earlier, log filters, log alarms, data analytics, image recognition, speech recognition, medical diagnosis, robotics, all these kind of things might be machine learning use cases. About speech recognition, I always thought that Finnish language is safe because nobody speaks Finnish. So I always thought that if I speak Finnish, none of these things will understand me. So my husband took me to the airport, and I mentioned one taxi company on the way there. I said, oh, there's a new taxi company, this ABC. I have never heard about that before. Maybe next time I will use it. I open Facebook. What happens? You might want to try this taxi company ABC. Okay, so I was only speaking. I didn't even type it anywhere. Then I played my husband. I said, it's your Android. It's definitely not my iPhone. My iPhone is safe. It's Android. So, week 2 later, I'm making coffee. You know, Finns are heavy coffee drinkers, so we have like 1 billion different coffee brands. And there's a new one. And I go and buy this new coffee brand. I make it in the morning, and I tell my husband, oh, I really don't like this new coffee. It's too mild for my taste. So only my phone is in kitchen. His phone is somewhere very far. And what does Facebook do? You might be interested about this new coffee brand. I'm like, seriously? You spy on me. But it doesn't know Finnish enough yet, because I said, I do not like this coffee. It thought I liked it. So I'm still kind of safe. Another example of my spying things is that I'm using the Oracle Cloud, and there's one button I really press quite often, and then I open the cloud, and the button is gone. So I start swearing. You know, Finnish swearing words are very efficient. So I start swearing to my laptop. I'm like, where is this button? I find the button, but I already used a lot of words for that. I'm like, this is the most stupid thing to do. You put this button somewhere, very hidden place, and I need it all the time. 2 days later, I'm presenting in Israel, and I open this cloud application, and the button is back. I said, there's only one explanation. Larry Ellison is listening to my laptop. It can't be anybody else, because it would have taken a week. Now it only took 2 days. So I'm sure about that. So machine learning is very cool. But what is not cool with machine learning is that if you don't understand that, it's not a fact. So whatever the machine learning says, it is not 100% sure. It's a sophisticated guess. So it might be 98%, 96%, whatever, but it's just a sophisticated guess. And especially if you get wrong kind of data, you will get wrong kind of predictions. So like deep learning example, there was a very good deep learning program that could recognize dogs and wolves. You know, it's very difficult to recognize if it's a dog or a wolf because they're very similar. But this program was like 100% sure every time which one it was. This is a dog, wolf, dog, wolf, wolf, dog, every time, until one picture came. It was obviously a wolf, but the program says it's a dog. Then the researchers are like, what happened? Why is it wrong? Because it always knows which one it is. Do you know why? Because dogs were always on the grass, wolves were always on the snow. So instead of recognizing dogs and wolves, it recognizes grass and snow. And this wolf happened to be in grass. So of course it's a dog. This is grass. So even though it looks like it's very accurate, but if you give it wrong kind of data, it will give you the wrong kind of answers. So machine learning can be very tricky if you are not careful. But for sure, it's not 100% sure. So some of these answers are better than others. Some are even useful, but some are just completely rubbish. And that's why we are needed. I hear a lot of people saying machine learning will come and take over and I will have no job left. You do have a job left because you have the brain. You have the experience of world. You know what's possible, what's not possible, and what makes sense and what doesn't make sense. So we do have a job here still. So what machine learning does, it searches for patterns, it searches for trends, it analyzes a lot of data to find something useful from that data. Usually prediction accuracy is the one that we are looking for. It might be a different kind of metrics as well, but usually it's accuracy that we are after. there's several possible models that you could be using. Your job is just to find the best one that will fit here and apply that to production. But still, it is an approximation, it is not a fact, even though it is the best possible model. So when I started with machine learning, what I found the most difficult was the words. People were using very strange words, and the same word possibly meant different things, and there was 4 words that actually meant the same thing, and I was so confused. I started with reading all kind of research papers, and I was so lost. So I was thinking I will explain some of these words to you to make your life hopefully a little bit easier. So a task is the problem that we are trying to solve using machine learning. What are the customers that are about to leave my company? If this is the beer I want to drink, do you think it's a good beer? Should I drink it or not? Because I can only drink 1 beer. Which one should I take? Do I have any customers that I should be selling insurance? So I have 1 billion customers, but I don't want to call each of them. So do I have a subset of those customers that are most potential to buy the insurance, so I can have a shorter list to call? So this kind of use cases would be the task. So the business task, what do we want to achieve using machine learning? The algorithm is an experience for the computer to learn with, and it solves the learning problem. Using that data we have and the algorithm, we produce a model. A model is the output of the machine learning. So using this model, we will have the output, the prediction for our task. But then we have features or dimensions. A feature or a dimension is an individual measurable property or characteristics of a phenomenon being observed. This is how Christoph Bishop said in 2006 in his book, so what he thinks features are. And deriving features, feature engineering, feature extraction is one of the most important parts of machine learning because it makes it more efficient and more accurate. It turns data into information that the machine can really use. So features are like the temperature or the weight of a person, color of my laptop. These are features. So like attributes or columns in a table, this kind of things, they are features. And using those features, you make predictions. Then we have methods and techniques. There's 2 main categories. There's unsupervised learning and supervised learning. Then there's also semi-supervised, but I don't go to that area. Just the main terminology here. So the task is most important. So you need to understand what you are trying to do. Because if you define the task wrongly, I am trying to find, well, in my example, I want to find good beer. What on earth is good beer? So I want to know if beer is 5 out of 5. Would be more like a question for machine learning than find me good beers. Because I don't have a definition for good beer. So it's very important you define the task well, because first of all, then you will understand the question you have, and secondly, you will go and find the right kind of data for your question. If you haven't defined the task, you might have completely wrong kind of data for your task to be solved. So machine learning is not just mathematics and statistics and so on, it's also about your business. So how will your business benefit from using machine learning? Algorithms are the experience for the computers. We have experience by living our life. We learn things, we make mistakes, we learn and so on. But the machines don't have that, they only have algorithms they can use. Finding the algorithm is of course one of the issues here, so what algorithm would fit me the best? Try and error is the way to find it. So which algorithm should I start with or select or whatever? It depends. The size and type of data you have, the insight you want to get from the data, and how those insights will be used. But whatever it is, it's always a trade-off between different factors. So predicting accuracy of new data, speed of training, memory usage, transparency, interpretability, there's always things that you will get, but other things that you will lose. So you cannot have everything at the same time. So you should decide yourself what is important to you. Do I have to understand exactly what the computer is doing, or do I want it to do just fast? Or do I just want it to be accurate and I don't care about anything else? I will bring more memory, more disk, whatever is needed. I just want it to be accurate. There's different kind of models, geometric models, probabilistic, logical, grouping, grading, different kind of models. But that depends on what you're actually doing, what kind of model will work for you. But a model is only as good as its features. So I talk about tables because that's usually easier to understand. If your table have 100 columns and you use all the 100 columns to define the prediction, it probably makes no sense because there's probably descriptions, there's all kind of things that has nothing to do with the prediction. And if you use all the 100 columns, it will take a lot of memory, a lot of space, a lot of time, a lot of everything. If you can achieve the same with 2 columns, the same accuracy, the same power with 2 columns, why would you use the 98 other columns at all? So finding the right features to do predictions is very important. And it's also interaction between the features. So, and also how useful the feature is. Let's say I'm selling a house. And I know the GPS coordinate of houses, and I want to predict the price for that particular house. GPS coordinate sounds like a very good feature, but I cannot compare two GPS coordinates. This house GP coordinates is this, and this house is like this. Which one is better? I don't know. So instead of using that GPS coordinate, you might transform it to something else more useful, like close to sea, in the middle of the forest, walking distance from the city center, still in the middle of the forest. So you might want to transform that to something that is really useful for predicting the house price. So features might be useful not as they are, but as transformed to something else that they can be easily done. But in short, machine learning is you use the right features with the right algorithm to build a right model that achieve the task that you're actually trying to achieve. That's my kind of definition for machine learning. So I said there's 2 types of machine learning, unsupervised learning and supervised learning. This is very easy to define how they are different. Unsupervised learning is learning from unlabeled inputs. So you just have data, you have no idea what you have. And you're trying to find something useful from that data. So you actually don't know what you are doing. You don't know you want to predict what is the house price. You just want to find something useful from the data. Maybe you don't have a specific goal. Maybe you don't know what you are even targeting here. You just have data that you have a feeling is useful. You might want to use unsupervised learning as a pre-process for supervised learning, to find something from the data, some kind of logic from the data. This might be my unsupervised data. So there's just a lot of rows of data that makes no sense to me. From here I see there's LAX, which I know since I was in Los Angeles, that it's the airport there, but I also need it means salmon in Swedish. Maybe it's lax. I don't know. So I can guess what my data has, but I actually don't know what it does, what's in there. The thing we do when we do unsupervised learning, the most typical thing is clustering. So I tell machine learning, put my data in 3 clusters. This 3 is, by the way, a hyperparameter. I will tell you that later, what's hyperparameter. But I say, put it in 3 clusters. It takes all my data points and puts it in clusters. It finds 3 clusters, and then it makes somehow sense to me. I have 3 different kind of things based on people who like ice cream, people who like chocolate, and people who like salmiak. That's it. Clustering is the most common method when we do unsupervised learning. There's 2 ways of doing clustering, the hard clustering or the soft clustering. The hard clustering means that when we have a data point, it can only belong to 1 cluster. While as when we do, well, there's some examples here of those algorithms, like k-means or k-medoids might be examples of this kind of algorithm. While when we do soft clustering, this 1 data point can actually belong to 2 different or 3 different clusters. So that's the difference between hard and soft clustering. Examples of these algorithms, fuzzy C-means or Gaussian mixture model. Supervised learning is learning from known data. So we have known input, we have known output. Like the beer example, we have beers, we already know this is beer ABC, and people has rated it 5 out of 5. This beer, people have rated 1 out of 5, and so on. So we already know what is the outcome. So we need to have this kind of data to be able to do supervised learning. So we are using this known input, known output for training and for testing. But again, I mentioned earlier, when we have the data here, we have to split it in 2 parts, training and testing. Because if we use the same data to train and to test, we are cheating, because it already knows the answers. We already trained it with that data. So we need to have new data to test if it works. And it has to be the data that we know the input and the output, so that we know if it's correct or not, whatever the prediction is that comes out. Okay? Make sense? Yeah? So this would be data for supervised learning. It has some kind of headings here telling that actually the LAX was an airport name. So it does have the name of the data, so the kind of labels for my data. And also for supervised learning, important is that we have the target known, so we know what we are trying to predict. We are trying to predict the accuracy of the flight, how many times the flights are delayed, or how much are the flights delayed in general. What is the air company that is most delayed? What is the beer that would get 5 out of 5, or would get 1 out of 5? So we know what we are trying to target after. Those customers that would like to buy the insurance, the target is will buy the insurance, okay? So what are we getting out from machine learning? The process is something like this. First we train. We load data, we pre-process the data. This is 80%, 90% of our work. So most of the work with machine learning is something you do every day. If you build a data warehouse or somehow use the data in your company, you have to somehow understand the data and somehow manipulate the data. There's probably missing values, there's probably wrong values in the data, so this is the process that you do before machine learning can start. Then we learn using a method and an algorithm, and we create the model. We iterate this as many times as we need to be able to have the kind of way that really works sufficiently enough. When we are happy with it, we have a model that works very well. We have maybe 3 options, and this is definitely the best one. We will take that and we will test it. We will predict with new data, known input, known output. We pre-process the data again. There's missing values, there's mistakes in the data, and so on and so on. 80% of the work, 90% of the work. And then finally we give this data to our model to give predictions. Then we see the predictions compared to the real value. Did it really work or not? If it's good, we go to production with the model because it's perfect. But if it doesn't work, we have to go back and start training again. It didn't work well enough for us. For supervised learning, there's maybe 2 most known ways of doing it, classification and regression. So what's the difference between these 2? Classification is we put things into classes. Customers who will buy insurance, customers who will not buy insurance. Beers category 1, 2, 3, 4, and 5. So we have kind of categories for our data. This is what classification is about. Is an email genuine, or is it just a fake or spam? Is a tumor small, medium, large? Is a person creditworthy or not? So this would be classification, putting things into categories. Some examples: K-nearest neighbor, Bayesian neural network would be this kind of examples, putting things into classes. Or maybe decision tree backed and boosted decision trees. Then we talk about regression. Regression is about numbers. What will be the temperature next Monday in Stockholm? What will be the price of a Nokia stock next April? So this kind of examples, it's about numbers. So what number would it be? Then it's about regression. That's regression. So you're finding the way to predict the next number. Okay? So you are predicting continuous responses, like changes in temperature, fluctuation in electricity demand, some kind of number. What would be the next number? Linear regression, non-linear regression, generalized linear model would be some examples of these algorithms. What algorithm do I have available depends on the language I'm using, my programming language. So what kind of algorithm it offers me. I can't say this is the best algorithm, none of them is equally good with this, they are just rubbish. No, they're all good. It just depends what you are trying to do. So depending what is your programming language, you will have some algorithms available. But definitely for all these needs, you will have at least 3 algorithms available, which should be enough. Then there's also a thing called anomaly detection. So that is to find something abnormal. So is there something that is not what it should be? This could be unsupervised, supervised, or semi-supervised learning, depending what we have. My example here is supervised because I have a value, I have a time, and I have defined that if it's between this and this value, it's fine. If it goes below or over, it's not fine. Alarm me for that. So we are finding something that is not normal, and then we react to that. That could be something like somebody is trying to hack your database, or something like that. So a lot of logging suddenly coming to your database without knowing the password, or something like that. Could be anything. So we're happy with the model. We just built the best model in the planet. Everything is working very well, except something changes. The world is changing somehow. The data has changed, or the requirements change, or whatever happened. It's just too much data and we don't have enough resources or something. So we need to improve the model. This will come one day, believe me, even though everything is so perfect today. So you might want to increase the accuracy and the predictive power of your model. It's not good enough anymore, for some reason. You want to increase the ability to recognize data from noise. There's so much more noise than it used to be. We have to get rid of the noise, so we have to recognize when it's noise and when it's real data. You want to increase the performance because it's getting too slow. It has to be faster. You want to improve whatever measure that is so important to you that is not good enough anymore. But there's some techniques you can use. I already mentioned that if you have 100 columns and you try to use those to predict something, it is not as powerful as it would be with 2 columns. So you might want to reduce the features without losing the accuracy, but gaining performance. Just example. Technique for that would be feature engineering, which could be feature selection or feature transformation, feature extraction. Or it could be hyperparameter tuning. Let's see what that is. So feature selection is also called variable selection or attribute selection. So we are identifying the most relevant features that will provide the best predictive model for the data. So we are trying to find as few features as possible that will give the right accuracy for us. So not if 5 can do it, but also 4 can do it, and also 3 can do it. Why would you use 5 when you could do it with 3? These 2 will not bring anything new to our model. But the performance will be so much better with just 3. It could be also adding features if your accuracy is not good enough. If 3 is actually not giving accuracy, you might need to add the 4th. So finding the right number and the right features is important. So feature selection techniques, I put here a lot of words, so if you are interested, you can Google more, because I only have 50 minutes, so it's not much. This is a broad topic. You can do stepwise regression, sequential feature selection, regularization, or neighborhood component analysis. And feature transformation is a dimensionality reduction, also meaning the same as I mentioned earlier, the feature reduction. So you are reducing the features. I skip these. And also these I just mentioned here. So for feature transformation, you could use principal component analysis. You might have heard about this, PCA. It's quite popular. Factor analysis or non-negative matrix factorization. I put some slides here so you can read more about them. Principal component analysis, factor analysis, or non-negative matrix factorization. So these are in the point when you need to be optimizing your model. It's not good enough for some reason anymore. Hyperparameter tuning. I mentioned in the beginning that when we were doing clustering, I will tell the machine, I want to have 3 clusters. Number 3 is a hyperparameter. So hyperparameters are those parameters you define before you start machine learning. Depending what you are doing, those parameters are different, but the idea is that you define them before starting machine learning. Number of clusters, for example. It's an iterative process again. The classical example would be probably deep learning. When you have the neural network, you define a lot of hyperparameters for the neural network before you can start doing it. Then you will go backward propagation to actually fine-tune them afterwards when you realize you didn't have the correct ones guessed in the beginning. By the way, if you guess them in the beginning, go and do lottery. You are probably very lucky that day. So usually it is a try and error process with hyperparameters as well. How do I know what to tune? Well, it depends. What is important to you? So you cannot tune anything if you don't know what you are measuring. So what is important to you? Number of positives, number of negatives. What is important that you should be measuring? Is it just the accuracy or is it something else? When you know what you are measuring, you have to define what value should it has. Should it be accuracy like between 0.5 and 0.7? Should it be between 0.9 and 0.95? What would be something that you could accept as a value? Then if that value range is not met, you need to be improving. Okay? How to measure and how to interpret those measures. You have to define it. So I want my accuracy to be between 0.8 and 0.9. If it's not there, we need to do something. There's a technique. Let's talk about accuracy because most of the time accuracy is important. There's one technique, well, several techniques, but this is the most popular one, I would say, cross-validation. So cross-validation is also called rotation estimation. I need 2 hands now. So it goes like this. We have data. We split it, let's say, in 10 pieces, like this, equal pieces. We use 9 first one to train, and the last one to test it works. We rotate. We use these 9 to train, and this to test. We rotate. We use 9 to train, 1 to test. We rotate, so that each of these 10 pieces is in each role in my cross-validation. After that, we know if it's accurate or not. I said I will mention something about Oracle. So a shocker to me was last September at Open World when Oracle announced the free cloud. So now you are able to just set up a cloud for free and test Oracle, whatever they have in a cloud. I thought this is the coolest thing that can happen in this planet because Oracle has known to be expensive. Now there's a free cloud. You just sign up and use it. There's, by the way, a booth here if you want to go and do it here. So you just go and use it for free. Last summer, they announced that in this cloud, they have pre-installed Apex, which is one of those IDEs that you could use for building applications. Low-code one, very easy to use. There's ORDS, SQL Developer, and so on in the cloud. But the coolest thing was yet to come. December, they said that machine learning is free to use. So what Oracle has for machine learning and also spatial and graph is free to use. So if you set up the free cloud, you are able to use machine learning for free. So what do Oracle have? They have actually PL/SQL packages that you can use for machine learning. You can do analytics, predictive analytics, you can do transforming, you can remember the GPS coordinates of the house, so you have to somehow transform the data, that's package for that. And you can do also data mining, building models, applying models, and so on. So this is how to do it. I had a demo, but I'll skip it because I'm running out of time. But there's 100 billion different other languages as well. So most of the times when I speak about machine learning, somebody asks me, Heli, what language is the best? Well, that depends on you. So what is the language that you feel more comfortable with? Use that language. Because I'm sure that language has those libraries you need for machine learning. Because if you start with a new thing, machine learning, keep something that you already know, your programming language, and start with that. Then you will gain more knowledge about machine learning, and after that, you can maybe change the language if you feel like. But start with something you already know, so it's not too much new things coming out. Another question that always comes out, what on earth is deep learning? Very briefly, deep learning, I have a prediction here. I have input, I do feature extraction. Remember what 100 features or 3 features would be the right features to get the accuracy enough, okay? And then I do classification, and output is, it's a car. What actually happens in deep learning is I don't have to do feature extraction. It's doing it for me automatically. So why is not everybody using deep learning? Because, well, it takes so much data, so much resources, that most of the time you cannot use it. It's mainly used when you have several layers, like you have computer vision, face recognition, speech recognition, text processing, that kind of things. But you need a lot of data to be able to do deep learning. So 100,000 rows is not enough. So you need a lot of data and a lot of resources. I put one example here, which I can't show you because of the time, but there's a machine learning algorithm that will create your, let's say, abstract for your presentation. You just put a couple of words and it will create the rest of your document for you. Very funny. So the link is here. So what deep learning is using and why it's so popular nowadays is one of the inventions, convolutional neural networks, and this is how it looks like. So dog picture in, and output will say if it's a cat or dog. And there's a lot of things in the middle. Hopefully next year I will talk to you about deep learning more. It's a very exciting topic. So what if we don't have data? Or what if we don't want to have a prediction? We want the computer to learn something. The example here, if you want to check, is car learning how to park. So we know, like, you are not allowed to hit the next car, you're not to hit this and that, you just have to go and drive safely to your parking slot. It takes like 50,000 rounds for the computer to understand all these things that we know by nature. So if you don't have data and you just have to teach the computer to do something like park the car, you will be using reinforcement learning. You have agent, the car, the environment, the parking area, and then rewards. You hit the car, minus points. You made it well, good, 1 point, this kind of thing. So there's so much about machine learning, not just what I told you now, but a lot of other things as well. Multitask learning, online machine learning, active learning, adaptive intelligence, a lot of different things. But whatever you think about these, I tell you one thing. Artificial intelligence and machine learning is here today, and it will stay. So whatever effort you put to machine learning to learn it, it's all good. Because you will need these skills in the future, and you will have a job in the future if you know about machine learning. This is here to stay. But not just that. This is super exciting and interesting. So there's always new things to learn, and it will just give you the rewards every time. You will be like, reinforcement learning yourself. So it's super exciting. It is here to learn about machine learning because of the big data, because it's used everywhere. Machine learning is everywhere. There's unsupervised learning, supervised learning, reinforcement learning, improving the models, defining the measures. So much to learn about machine learning, I can't even breathe anymore. So thank you so much for attending. Here's my Twitter handle, here's my blog. I blog about database designing nowadays. One day I will blog about machine learning when I have the time, currently not. Feel free to come and ask me questions afterwards. I will be here to answer. Thank you so much for attending.
Thank you.